Greetings and salutations, fellow YouTubians. My name's Terry Andrews Jr., also known as the J5 Guru, and this is the test that many of you have been waiting for. So this is a test of the Eccentric drive for the Johnny 5. The Eccentric drive, I designed it. I had a lot of help, a great deal of help with the actual, modeling and the mathematics involved from Andrew Friedberg, who did the CAD work, who said, hey, I had the basic design, and hey, I want I want this kind of arm cam, things like that, and he did the magic to make it all fit, and it barely fits in the Johnny 5 cradle base. So yeah, there was just a ton of research and development. The actual funding for the research and development was provided by Tyler Hoth, who, because it's at one point I was like, I just don't have the money to continue to develop it any further. Linear actuators were used in the original robot, but there were problems. One, the Johnny 5 that was at Eric Allard's that I worked on, those actuators had failed. The linkages inside were bent for the rear caster. The whole track tip would move freely, which it should not have, because the linear actuators would hold it in place. And it wasn't until afterward where I actually seen the video and realized that, hey, those actuators actually failed. I did come up with another solution, which was way back there up at the top. You can see those long linear actuators hanging. Those are SKF actuators, CAR 40. They have to be heavily modified, shortened. The motors alone are, geez, a few years ago anyhow, $350 each. You would need two of them. You need two actuators. They were out of CAT scan machines, used. A whole lot of work and a whole lot of money. Those actuators are not cheap. So, okay, so excuse the crudity of this video. I tried setting it up over there, facing this way with the GoPro camera. The GoPro camera just isn't working right. It's losing communication with my phone. It just, I don't know. Supposedly they are, kind of top of the line products. I'm not feeling it. Yeah, mine just won't stay synced up to my phone. So yeah, we're stuck with the webcam here and this crappy kind of view. Okay, so this is the Johnny 5 cradle base. I will tell you that the rear caster is fixed in place. I don't have the linkages. The cradle base is the old cradle base, the original prototype. It's been slightly modified and the geometry corrected and changed, so it will not accommodate the new setup. Okay, so I have a 15-pound solid steel gear inside the cradle base. I have 4 10-pound weights also in the cradle base. I have 2 40-pound weights on the track drives right in line with the track tip tube. Each one of the tracks themselves in their current configuration weighs, I wrote it down, 20.6 pounds. The cradle base itself I also wrote down, and that is 52.4 pounds. I forgot to weigh the rear caster and upper and lower A-frame, so I didn't even include them in. So all together, the way you, oh, and there's a granite block on here. Yeah, that's 80 pounds. Okay, so all those added together, 307 pounds. Okay, so we'll go ahead. I have this running off of a set of 35 amp hour lead acid gel cell batteries. Actually, they're not gel. Yeah, they are gel cell. So let's see what this does. Remember, the target was up in 4 seconds, down in 4 seconds at a maximum. Anything faster, that's great. So here we go. should be noted at the top of the rotation. You'll notice it's not back driving because it's an eccentric drive. When it reaches its uppermost limit, it is physically impossible for it to back drive the system. It's just, nope, not happening. Same thing in the lowermost position, okay? So it is a self-locking mechanism at both extremes of the travel. And this is running in one direction. It can be servo-driven. It can run forwards, backwards. But effectively, if things go wrong, nothing's going to happen. If the power is somehow interrupted, a fuse blows or something like that during the track tip, what I'll do is I'll simulate that. I'll start going down and then shut the power off, and you'll see all it does is go down to full low, which is where you want it. You don't want it tipped up like this. So see? It's great, isn't it? So you're saying, yeah, that's great, 370 pounds. We guesstimate the robot may weigh 350, possibly 400 pounds. You know, we're not quite sure. So, yeah, hey, man, let's turn this up to 11. Let's do this right. So we've now added 213 pounds to this, so we're now at 520 pounds. Let's see what this does. How about that, folks? And again, I'll take it up and I'll show you it locks. Right there, it's locked. It's not going anywhere. Okay? And if I take it a little bit past the eccentric locking point, it will just lower down. See? All right. So, and I might add, these batteries are actually, they haven't been recharged. Let me check quick the actual voltage of these things. I'm sure it can't be very high. I mean, I checked it before these tests. It was 24 volts. And we are currently at 24.3. And these batteries are like 10 years old. But I do know from previous testing yesterday that maximum with me on here, I was drawing like 16 amps of current. And so here we go. So I ran the numbers again this morning, and basically I have a mechanical disadvantage of 5.6, okay? Which means that every 5.6 pounds of pulling force that's being applied to the cam in the cradle base is only generating 1 pound of force at the ends, okay, at the front roller. So, what does that mean? That means if we're lifting 520 pounds, which, let me see, for my friends in the UK and all the other metric countries around the world, that's 235.8 kilograms. So, at a mechanical disadvantage of 5.6, we're generating a total pull inside of this cradle base of 2,912 pounds, or 1,456 pounds per side, okay? And we're doing that with two RS775 motors. Amazing. That's the nice thing, you know, you can see when it goes up, it self-locks. When it goes down, it self-locks. The motor is not, nope, There's no power being drawn from anywhere. It's an inherently robust design, and it works. It works quite well. So yeah, so what I'm going to be doing is I'm going to be taking this out, transplanting, going forward, moving forward. I would like to thank everyone on my team. That'd be Martin Pinner, Andrew Friedberg, Ramon Rivera, Kyle Daytona, Sean Fox, Dave Hall, Dave Stapley, Tyler Hoth, big shout out to him. He actually funded all of the research and development for the Eccentric drive. Yeah, I could afford to do no more. And then a huge shout out to John Saunders and Ed Reese at NYC CNC. They did the machining of the actual arm and the eccentric cam on the inside. They've just been wonderful to work with. Hey, we've been, they're building their own Johnny 5. They're doing all the cool CNC stuff. And they have a much higher video production value than I do, of course. But yeah, they are doing absolutely fantastic things. They go around the world and they interview people and they go to different factories and they teach classes at their company, their shop. They sell, different types of tooling, plates and fixturing, and they're just, man, NYC CNC, yeah, check them out. Go on YouTube, NYC CNC, do a search for them. They'll pop up. Hey, John and Ed, thank you, man. You, because one thing they, of course, that I can't do is my tiny little gantry machine will not CNC steel. So they've been a great help, and I'm doing everything I can to help them out with their build. So let me see. Is that everyone? I think that's everyone. We do have a teammate up in Canada that's having going through some rough times right now, and we're hoping that he comes back to us soon. Yeah. So anyhow, that's about it, folks. I hope you found this informative. Yeah, linear actuators, would they work? I mean, with the forces we're talking about here that are required and necessary, if an actuator does fail, it overextends, it over retracts. Yeah, we're looking at like 3,000 pounds at a minimum to get this to work, and I'm quite confident this actually puts out quite a bit more. It's just that I have aluminum cams in there right now, and quite honestly, how much more does it have to do, It's not like we're going to be, carrying around elephants on this thing. So, yeah, that's about it, folks. All right, yep. So, again, excuse the crudity of the video. Terry Andrews Jr., also known as the J5 Guru, saying bye for now, and go build something cool. Alrighty, and the monkey pushes the button.